Refractive index. This is incident ray. This is a refracted ray. N and N dash is normal. This is medium 1. This is medium 2. We assume that this is air and this medium is suppose glass. Now we define refractive index. Refractive index mu equal to sine of angle of incidence divided by sine of angle of refraction. It is also defined as ratio of speed of light in air divided by speed of light in medium. But we know that c equal to n lambda, where c is the speed of light in air, n is frequency, and lambda is wavelength. Since frequency does not change with change in medium, so V will be equal to n times lambda 1. Only wavelength will change. So if we put these values here, so we will get n lambda divided by n lambda 1, which will be equal to lambda upon lambda 1. Unit of refractive index. Since both quantities are same, so it will have no unit. Factors on which refractive index depends: nature of medium, wavelength of light, temperature, nature of surrounding medium. Now, principle of reversibility. This is incident ray and this is a refracted ray. Now, if a mirror is placed in the path, then this ray will retrace its path. So let's see what happens. So at point A, we write refractive index of second medium with respect to first. So we write it 1 mu2 equal to sine I divided by sine R. Now, when ray retraces its path, then refractive index of first medium with respect to second medium will be 2 mu1. This time we will take this angle in numerator. So sine R divided by sine I. This is equation number 1. This is equation number 2. Now we multiply 1 mu2 multiplied by 2 mu1 equal to sine I upon sine R multiplied by sine R divided by sine I, which will be 1. Thus, 1 mu2 equal to 1 upon 2 mu1. Example, suppose the refractive index of glass with respect to air is 1.5, then a refractive index of air with respect to glass will be equal to 1 upon 1.5. Here, suppose we write A mu B. It means we find the refractive index of second medium with respect to first. Now, refraction through a combination of media at point A. We write 1 mu2 equal to sine I divided by sine R. Suppose this is equation number 1. Now let's go to point B. At point B, we write 2 mu3 because this is medium number 2. This is medium number 3. Here, light ray enters from medium 1 to medium 2. That is why 1 mu2 equal to sine I upon sine R. At this point, light ray enters from medium 2 to medium 3. So we write 2 mu3 equal to, we take angle of incidence as R. So sine r divided by sine r1. Suppose this is equation number 2. Now at point C, here ray emerges in air again, so this angle will be equal to this angle. So at this point, since ray enters from third to first medium, so we write 3 mu 1. We take angle of incidence as r1 sine r1 divided by sine I. This is equation number 3. Now, if we multiply all three equations, so 1 mu 2, 2 mu 3, 3 mu 1 equal to sine I upon sine r multiplied by sine r divided by sine r1 multiplied by sine r1 divided by sine I. So each term sine I, sine I, sine r, sine r, sine r1, sine r1 will cancel out and we will be left with 1. So we can say that 1 mu 2 multiplied by 2 mu 3 multiplied by 3 mu 1 equal to 1. Let's take an example. Suppose we are given three media, air, suppose this is water, this is glass, and then next one is air. So applying same rule, at this point, suppose this is incident ray and this is refracted ray. So we write at point A, we apply the formula, and this is suppose angle R. So here we say light enters from air to water. So we write A mu water equal to sine I upon sine R. Now at this point, so here ray is entering into glass. So this angle will remain R and this is suppose R1. So since ray enters from water to glass, so we apply the formula glass water to glass. So refractive index of glass with respect to water. So at this point we write sine R divided by sine R1. Now again, at this point, ray will enter in air. So this angle will be equal to this angle I. So we apply formula of refractive index here again. So since ray enters from glass to air, so we write a refractive index of air with respect to glass. So G mu A will be equal to sine R1 divided by sine I. If we multiply these three equations, so again we will get 1. A mu W multiplied by W mu G times G mu A must be equal to 1. Now let's find out the refractive index of glass with respect to water. Suppose we are given information. So A mu W equal to suppose 4 by 3 and A mu G equal to 3 by 2. And we have to find out W mu G. So we can apply this formula A mu W, W mu G, G mu A equal to 1. So suppose this is equation number 1. So we put the values. A mu W is given as 4 by 3. So 4 by 3 into W mu G into G mu A. If you remember, I told you A mu G times G mu A will be 1. This is similar to 1 mu 2 into 2 mu 1 equal to 1. So from here, if A mu G equal to 3 by 2, then G mu A will be 2 by 3. So 2 by 3 must be equal to 1. So W mu G equal to 1 into 9 by 8. So this is W mu G equal to 9 by 8, which is our answer. Thank you for watching.